All right. So we are doing Chapter 5 Integration, Section 5, the Fundamental Theorem of Calculus. But notice we jumped. We went from 5.1, 5.2, and then we jumped to 5.5. So there's a couple things I want to add for that little bridge. So let's kind of back up just a little bit. Take out a nice sheet of paper. First thing I want to back up, I wanted to have you a nice one page of all the special case intervals. All the special case intervals, okay? So special case intervals. I'm going to add some. They may not be commonly used. You'll see which ones we use more than others. But let's just have one nice page of the commonly used intervals. First of all, what's the integral of e to the x dx? What's the integral of e to the x? E to the x. Don't forget your plus c. So we've done that a lot to show how important it is. Okay? The other special case one we've used is when you're taking the integral of 1 over x dx, or it could be written as the integral of x to the negative 1 dx. We said that's a special case because if you try to add 1 and divide by it, you get 0. So what's the integral of 1 over x dx or the integral of x to the negative 1 dx? That one is ln absolute I of x. Don't forget your plus c. Okay? So those are the ones we already know. Those are the ones we already know. Now we're going to add a couple. Not as popular. I still want to go over it, but if it looks like this, this is what you do. Okay? So here are some other ones. What if I had the integral of some base raised to an x dx? What if I had the integral of some number raised to the x dx? Okay, well, how would you do that? The integral would be you rewrite it over the ln of a, ln of the base, plus c. Okay, so that's a new one for us. How do you take the integral of some number raised to the x dx? You rewrite it over the ln of a. So since it's a new one, let me give you an example. So let's say with an integral of 2 raised to the x dx. Let's say we have the integral of 2 raised to the x dx. What would you do? Step 1, rewrite it. 2 raised to the x over ln of the base is 2. Don't forget your plus c. So again, these are special cases. The reason why they work is if you took the derivative, you'd get the original back. But they're not as common. Okay? A couple more. Let's say I asked you for the integral of ln of x. The integral of ln of x. The integral of ln of x, again, we just kind of follow a formula, would be x ln of x minus x plus c. Now again, that's kind of long, but if it looks like integral of ln of x dx, that's what you get, x ln of x minus x plus c. So if you happen to get ln of x, the integral would be x ln of x minus x plus c. And why does it work? If you took the derivative of this, you would get the original back. If you took the derivative, you would get the original back. Okay? And to add to that, let's say I had the integral of ln, let's say we had some number like 3x. What would be the integral of that? That would be x ln of 3x minus x plus c. So it doesn't really change much. It doesn't really change much if you had a number in front of the x. So again, special case, if it shows up, you know what to do. If it shows up, you know what to do. And the last one, the last special case, is what if I had the integral of log x dx. Now remember, if I just say log of x, what's assumed that the base is? What's assumed the base is? 10. So how do you take the log, the integral of log base 10 of x? That would be x ln of x minus x. Doesn't that look familiar? It's the same thing as natural log. Same thing as natural log. Divided by ln of the base, which is 10. So log and natural log have very similar integrals. The only difference is because it has a base, we have that little extra divided by ln of 10. And the very last one is, let's say I had the log, let's say the base wasn't 10. Let's say the base was 5. Well, the only thing that would change is x ln of x minus x over not ln of 10, but what would be ln of what? 5. Let's see. Well, again, this sheet is all the special cases that you need to know. The last ones are not as popular as the first two. You've seen me use the first two a lot. But now you have all the special case intervals. Zoom out for all of them? I'll do it now. Oh. So if you came in late, I'll give it to you. Okay? Are we good? So that's one thing that I want to make sure we cover all the special cases. Okay? The second thing is that we're skipping 4-3. It's okay that, sorry, 5-4. 5-4. It's okay that we're skipping 5-4, but there's some kind of ideas I want to give you from 5-4. So I'm going to briefly go over 5-4, but I just want you to sit back, relax, as I go over 5-4. Okay? So again, real quick, fly through a 5-4. Our focus today is on 5-5, but kind of sit back and let me give you the understanding of what 5-4 is about. When you take the integral, right now you have the best understanding. It's to go backwards. It's an antiderivative. So if I had marginal cost, you work backwards to get cost. If I had marginal revenue, it gets you backwards to original revenue. That's great. Another thing that integrals do is it finds the area under the curve. It finds the area under the curve. So we're just going to kind of look at what an integral can do. So when you take an integral, it finds the area under the curve. Another application, another reason why we do integrals is we find the area under the curve. So this would be the area under the curve, and let's say we wanted to be specific from 1 to 5. So we can be specific. Now, if I'm not specific, the area is everything under the curve. If I am specific, it's 1 to 5. So how can I tell if it's everything or 1 to 5? That's when the numbers show up. So again, this is just background. We're going to go a little quickly. How can I find that area by hand, or where does the idea come from? We can find the area of the rectangles under the curve. And in this case, the rectangles are on the left side. We find the area of all the rectangles, we add them up, and that will give us an approximation of what the area would be. So we work all that out, and we can find the area to be about 11.5. But we can also find the area using the right side. Again, this would be more than the rectangles, but it's an approximation. Last time it was a little under. Again, it's just an idea of how to find the area. So if we did the right sum, we get 17.5. So then we would know that the first one is under, the other one's over, so our area would be somewhere between 11.5 and 17.5. We're going to find it exactly using integrals a little bit later. This is just a concept thing to get the idea. Okay? And the more rectangles would give me a better answer. The more rectangles would give me a better answer. So it narrows it down between 12.875 and 15.875. Okay? So all these ways are to approximate, knowing that there may be an error involved. But it's the big things I want you to take away from this is when you take an integral, you're finding the area under the curve. And if I wanted to be specific, I can tell you not the entire area, but only from 2 to 5. Those numbers turn it from an indefinite integral to a definite integral. Definite integral means everything. Indefinite means everything. Definite means only from 2 to 5. So notice that if I only want 2 to 5, we're only focusing on 2 to 5. Okay? And the number of triangles helps us figure out the area. But all of this is to give us an approximation. Okay? The only last part to talk about, again, it's just finding the area under the curve, finding the area under the curve, is that what if I have some that are below the x-axis and some above the x-axis? Okay? So if I did have that, again, we're taking a definite integral has numbers, that a to b, these are called my bounds, lower bound, upper bound. That makes it a definite integral when I have numbers. But if you ever get the case where some of your areas below the x-axis and some of your areas above the x-axis, anything below the x-axis would be a negative. Anything above the x-axis would be a positive. So you'd find the areas, but anything below the x would be negative, above the x would be positive. So in this example, you would find all three areas, because what does integral mean? It means area below the graph. But in this case, it's below the x-axis. We'd make that negative. Below the x-axis, we'd make that negative. And then above the x-axis, we make it positive. So when you find the three areas and you added them up, remember, all the ones that are below the x-axis, we'd make negative. Above, we'd make positive. So when you'd add them up, you'd get an area of 2.11. Again, it's all concepts, just kind of understanding what it is. We talked about integrals before, and then now we're adding these numbers. And the numbers basically make it look for a certain area, Okay? So that's kind of what we're going to jump into when we get to 5.5. Okay? So what was the point of doing 5.4? What is an integral? Area under the curve. If I want the entire area, that's an indefinite integral. But if I want a definite integral, then we're looking at just this number to that number. Okay? So that's just a little background. Now we can jump into 5.5. Okay? So 5.5 talks about integration. And we're taking the integral from a to b, from a lower number to an upper number. And that's what makes it called a definite integral. A definite integral. Okay? So let's say, suppose the daily cost function for a manufacturing firm is given here. So we have the cost, and I want to find it from 0 to 20. So I have the original cost, and I want to find out from 0 to 20 is the entire graph. But let's say I only want 10 to 5. So how would I find what happens from 10 to 5? Oh, I'd plug in 10, I'd plug in 5, and I would subtract them. So this is what we're going to do today. Find out 10, find out 5, and subtract them. And that would give me the cost in between those two numbers. And again, this is all set up. So if I started with marginal cost, how would you work backwards to get cost? So if I had marginal, but I wanted cost, what would you do? You would take the integral. And when you take the integral, it would give me cost. Once I get cost, then I can plug in the upper and the lower ones and subtract them. So that's, again, still a little fuzzy. We're getting there, but we're finding the area under the curve. And that would give us our answer of 900. Okay? So what are we going to do today? Well, if I give you marginal cost, step 1 is we need to work backwards to cost. Integral. Then if I want to find between 5 and 10, plug in the 10, subtract, plug in the 5, and you're done. And the good news is we can do all this in the calculator to check. Okay? So again, this is still all set up, understanding, set up, understanding. So let's start with one. Let's start with, actually this is cost already. So if you had cost, you would plug in the 10, you'd plug in the 5, and you'd subtract. But if I didn't have cost and I had marginal cost, I'd have to work backwards to find cost. So this is kind of showing it again and getting our answer. So what do? Bottom line, if you had numbers That makes it a definite interval. Definite beginning, definite ending. You first find the integral, plug in the upper number, plug in the lower number, and subtract. That's what we're going to do here. All that setup was to get us there. Okay? We do know there's a C. We'll talk about what happens with that C. But let's start with this problem right here. Okay, so take out a nice sheet of paper. First, let's do it. Then we'll do some word problems that go with it. Okay, so all that setup is to get us right here. All that setup is to get us right here. So as far as we know, this looks like what we've been doing. But the only difference between what we've been doing and what we're doing right now is what? What's different? The numbers. That's it. Are we okay? So we'll do word problems and I'll explain what it means. But let's just do the work and then we'll get the explanation later. Okay? So step one, take the integral. That's step one. So pretend the numbers aren't there. Pretend the numbers aren't there. Let's just take the integral. So if I was going to take the integral, my first step would be to rewrite it. Instead of 3 over x, that would be what? 3x to the negative 1. So I want you to forget about the numbers right now. Just take the integral. So again, you need 5(1) and 5(2) in order to be doing 5(5). So step one, take the integral. If you don't know how to take an integral, that could be a problem. All right, let's take the integral, okay? When you take the integral, the 3 stays in front. What's the integral of x squared? X 3 over 3. The 2 stays in front. What's the integral of e to the x? The 3 stays in front. What's the integral of x to the negative 1? ln absolute value of x. And then every integral always has a what? Plus c. Stop there for a second. If you don't know how to take an integral, you cannot do this section. You have to build. Okay? So if there's your problem, you got to go back and study 5(1) and 5(2). I'm not going to say that 1,000 times to say it once, but really loud. Are we okay? Now, we always clean it up first, and that's a good practice because we're about to have a step 2. So 3 divided by 3 is 1, so we have x cubed minus 2 e to the x plus 3 ln absolute value of x plus c. So that is total review from 5(1) and 5(2). Any questions on taking the integral? We good? So the new stuff. What do I do with the numbers? What do I do with the numbers? So step 1 is to take the integral. Step 2 is now to deal with the numbers. Step 1 is to take the integral. Step 2 is to deal with the numbers. Are we okay? All that background showed you what we're doing is finding the area under the curve. We're finding the area under the curve from 1 to 3. Good so far? So after you take the integral, now I'm going to plug in 3. I'm going to plug in 1, and I'm going to subtract it. So all we're learning today, all we're learning in section 5.5 is, after you take the integral, which we already learned, everywhere there's an x, plug in the upper number. Minus, everywhere there's an x, plug in the lower number. Now, we don't want to make any assumptions, so take out your calculator and do this. Now, before you do this in the calculator, look up, look up, look up. What about the C? What happens to the C? What happens when you get C minus C? What happens? It's going to cancel. C minus C is 0. So, listen carefully. I'm going to say it one time. I'm going to say it really loudly. Because every single time we're going to get C minus C. Every single time we're going to get C minus C. When there's numbers, if you understand that, do I have to put the C anymore? Only when there's numbers, you don't have to put the C anymore because you know what will always happen to the C. They're going to cancel. Okay? So I already know that the C is going to cancel with the C. So from now on, when there's numbers, I won't put the C. If the numbers weren't there, you still always have to have a plus C. But only when there's numbers, you don't need the plus C because we know what will happen. Okay? So take out your calculator, type that in, see what you get. Take out your calculator, type it in, see what you get. If you type it in wrong, it will come out wrong. That's why it's very important that you practice that. And keep in mind, you don't have to type in everything. Like, for example, I can show you where the absolute value is, but what's the absolute value of 3? The absolute value of 3 is just 3. So you don't need to type in absolute value of 3. You can figure that part out. And let's just do 2 decimal places. When you're done, you should get negative 5.44. When you're done, you should get negative 5.44. So all we're learning today is when you have integrals with numbers, you take the integral first, plug in the top number, which is the upper bound, minus plug in the lower number. And we also know that you can put the plus C if you want, but it's not needed because we know every single time the C will cancel. C minus C is 0. Everybody get the same answers? And you want to hear the really good news? Because there are numbers, I can check it in the calculator. Because there are numbers, I can check it in the calculator. Are we okay? So let's go to our calculator, and I'm going to show you how to check it in the calculator. Ready? Now, your calculator may be a little different than mine, so definitely raise your hand, let me know, because there's another form of the calculator, which I'll show you in a minute. Okay? I want you to push math, which is on all the way on the left side, math, and go down to number 9. We did math 8, which is derivative. What's math 9? Integral. So choose math 9. And notice it looks like the problem we're doing. Now, if you have an older calculator, hold on, I'll do yours next. But what's the lower number? 1. Push to the right. What's the upper number? 3. Push to the right. Any questions there? And then let's fill it in. 3x squared minus 2e to the x plus 3 over x and then to the right, what's the last thing we put in there? X. Now, if you have the other calculator, I'll show you in a minute. Hit enter, negative 5.44. So the good news is with this, we can check everything. Now, if you have the other version of the calculator, which is no problem at all, here's what you'll be doing. It's kind of the same thing. You're going to hit Math 9, but it's kind of in a different order. If yours says FNINT, you're still going to put in 3x squared minus 2 e to the x, close parentheses, plus 3 over x. But then your calculator, you're going to put comma x, comma 1, comma 3. Lower, comma upper. Comma x for the dx, lower, comma upper. So it's a little different, but you still get the same answer. So depending on which calculator you have, that's what you're going to get. Are we okay? So either that version or this version. Are we okay? Questions? And then look at the work from top to bottom. Any questions? I'm going to make up one, and I'm going to make it up a little bit easier, a little more straightforward to see how we're doing. Let's take it from 2 to 5. X to the 4th minus 3x squared minus 4x plus 2 dx. Okay? So I want you to do it by hand first and then check it in the calculator. So we're taking the integral from 2 to 5 of x to the 4 minus 3x squared minus 4x plus 2. Take the integral first, plug in the 5, minus plug in the 2, and check it in the calculator. Okay, take the interval first. You have to know 5, 1, and 5, 2. Then plug in the upper number, plug in the bottom. Then check it in the calculator. Everything builds. And all that background is what you're finding is the area under the curve from 2 to 5. The area under the curve from 2 to 5. Then we'll do some more problems. And it will make a little bit more sense. Everything builds. Definitely check it in the calculator. Do it by hand, then check it in the calculator. Do it by hand, and then check it in the calculator.
Okay, that's it.
Okay, so let's see how we're doing. Step one, take the integral. X5 over 5, the 3 stays in front, X3 over 3, the 4 stays in front, X2 over 2. What's the integral of 2x? I'm sorry, 2x. And then normally we put a plus c, but because we know we have numbers, because we know the c will cancel, I'm going to first simplify this as 1/5 x to the 5th minus x to the 3rd minus 2x squared plus 2x, but then we have to plug in the 2 and the 5. Again, if you want to put the plus c there, you can, but we know it's going to cancel. If it didn't have the numbers, then you'd have to have the plus c. Now let me stop there and be very careful. If you can't take the integral, then you can't move on. You have to know how to take the integral first, okay? So any questions on the integral? Any questions on the integral? Okay? So what's the new stuff? Plug in the upper number 5. Minus, plug in the lower number 2, everywhere there's an x. And again, we talk about being careful for little mistakes. Be careful for little mistakes. If you plug it in wrong, if you type it in wrong, all these little things. But the good news is we can check it in the calculator when we're done. The good news is we can check it in the calculator when we're done to make sure we didn't make any little mistakes. Okay? So if you typed in the first one, 1/5, 5 raised to the 5, minus 5 raised to the 3, minus 2, 5, plus 2 times 5. Again, double check if one number is wrong, everything comes out wrong. What do we get for the first number? 460 minus what are we getting for the second number? What are we getting? Is it negative or positive? Negative 5.6. Negative, negative make positive. What do you get for a final answer? Now, if you made a little mistake, you didn't get that answer, but check it in the calculator. And when you check it in the calculator, plug in the original. Plug in the original, make sure you get 465.6. Make sure you get 465.6. Okay? And if you're not getting what I have up on the board, it's a little mistake. Okay? Be careful typing it in. Show all your work. But to make sure we get it, plug in the original into the calculator. So this would be math 9, 2 to 5, x raised to the 4 minus 3x squared minus 4x plus 2 dx, and you get the same answer. You get the same answer, 465.6. Okay? So more than likely, if you know how to take an integral and you understand plug in the top, plug in the bottom, subtract, then your mistake is something small. Maybe your sign, maybe you've got to be careful typing it incorrectly. Be careful, be careful, be careful. We okay? Questions? All the work step by step there. Any questions? Okay, now you're probably saying, well, what else can we do? Well, remember we learned U substitution. That was the last thing we learned. So there could be a U substitution problem. For example, what if I asked you to do the integral from 0 to 1 of 1 over 2x plus 4 dx? Okay, first of all, you probably rewrite it. So this would be the integral of 0 to 1, 2x plus 4 raised to the negative 1 dx. And I don't know how to take the integral of 2x plus 4 to the negative 1. So I'm going to do U substitution. So I'll do this one with you. Then I'll give you one to do on your own. So this will be U substitution. Why? It's a harder one. It's not just add 1, divide by it. So you tell me, what's going to be my U? Plus 4. Then if we follow our steps, the next step is to take the derivative of U with respect to x. What's the derivative of 2x? And what's the derivative of 4? Derivative of 4 is 0. Cross multiply, we went over all this last time. We get 2 dx equals du. Divide by 2, dx equals du over 2. So if you're struck U substitution, that's 5-2. You got to go back and study. If you don't know 5-1 and 5-2, you're not able to do 5-5. Okay? So let's not worry about the numbers right now, the 0 and the 1. But if I did the U substitution, this would be U to the negative 1 du over 2. Nothing cancels out, nothing crosses out, and it doesn't have to. But we just made something that was more difficult easier. So this would be the integral of 1/2 u to the negative 1 du. Have I taken the integral yet? Nope. What happens to the 1/2? Stays. What's the integral of u to the negative 1? ln absolute value of u. Don't forget your plus c. But that's not my last step, because I need to go back and put in what is u. U is, and I don't need the c because I have numbers. So I'm going to stop there for a second. We did like 10 U substitution problems last class. So if you're stuck on U substitution, even though we did 10 examples last class, you got to go back and study. But what my job today is to take it from here down. What's the next step? Plug in the 1, minus, plug in the, and then check it in the calculator. So plug in the 1, minus, plug in the 0, and then check it in the calculator. Plug in the 1, minus, plug in the 0, and check it in the calculator. Plug in the 1, minus, plug in the 0, and check it in the calculator. You can check the very original, or you can check the integral of 0, 1, 2x plus 4 raised to the negative 1. That's the one I'm going to use. But you can check it either one. But this takes practice. Plug But if you still don't know how to take the integral, still don't know how to do the integral with your substitution, how do you come with this now?
But then you have to reduce. But I can go from DU over to DU.
I know they have 2 on the bottom of 1/2.
Wait, no, I'm just using this that period.
This was going down. 2 on the bottom of 1/2. Yeah, it's not 2. It's 1 over 2. Yeah.
Oh, okay.
You understand? Okay, so let's see what happens. And I do want to tell you, just go nice and slowly, be careful. If you plug in the 1, minus, plug in the 0. Now, you don't have to do everything in the calculator. Some of you guys are really calculator dependent. I would figure this out first. 2 times 1 is 2. 2 plus 4 is 6. The absolute value of 6 is 6. That's a little bit easier to plug in, isn't it? Don't try to type in absolute value and all that stuff. Just try to do it in your head. 2 times 0 is 0, plus 4 is 4. I would put these in the calculator. That's a lot easier. But you can do what you like. This gives you 0.896, let's say.
Here we go.
Sure. And this gives you 0.693. And if you subtract 0.896 minus 0.693, you get about 0.203. Now again, you may be wondering, oh my gosh, what if I made a little mistake? What if I made a little mistake? What's the good news with all of these? You can check it in the calculator. You can check it in the calculator, okay? But if you're having problems doing 2 times 1 plus 4 is 6, or the ln, you have a calculator, it just takes practice, okay? Now, let's all practice in the calculator. I'm going to do this one up here, right here. And again, you can type in the original or that one, but I'm going to put math 9, 0 to 1, parentheses are important, 2x, 2x plus 4 parenthesis raised to the -1. Maybe the parenthesis was your issue.
Oh, we put the.
There should be a parenthesis there. Yeah, the original. You can do that. That is the original. Or if you wanted to type it as, you mean the 1 over? Yeah, same thing. Just again, be careful with parentheses. 1 divided by parenthesis 2x plus 4. That parenthesis does make a difference. That parenthesis does make a difference. But did everything match up? The work by hand and the work in the calculator. Okay? So let me add one. So I would like you to do the integral from, let's say, 1 to 3 of x cubed minus 5 raised to the 4, 3x squared dx. So is this going to be a U substitution? Yep. Oh, actually, let me back up. Let me back up a minute. There's something I want to teach you that's optional. I honestly prefer you to do it this way, but I need to show you other ways. So let's look at this one real quick. We did U substitution. I have U, and then I went back to X. Everybody with me? I'm going to draw a line here. there's another way you could have done this. I'm not really recommending it, but I do want to show it to you because the book shows it to you too. Is that, notice when I'm in terms of u, I have to go back to x. Is everybody with me? What if I didn't want to? What if I want to leave it as u? Well, guess what? You can. I can leave it as 1/2 ln absolute value of u, but my problem is 0 and 1 are in terms of x. So there's another way to do this, understanding that u equals 2x plus 4. So if I want to turn the 1 into u, I plug the 1 in for x. 2 times 1 is 2. 2 plus 4 is 6. That 1, which is in terms of x, is really a 6 in terms of u. And if I put the 0 in for x, 2 times 0 is 0. 0 plus 4 is 4. In terms of x, it's 0, but in terms of u, it's 4. I could leave it in terms of u and get the same answer. And you're like saying, wow, that's extra work. But to be honest, you're doing the work anyways. So I don't recommend it because I think it helps you to go back to x with what we learned. But you could turn everything to u and skip a step, sort of, or go back to x and you're going to get there anyways. So just understand they're the same thing, just which order do you want to do it in. Okay, so I wanted to show that just in case anybody wanted to do that. I don't think you would, but you may. But it's the same thing. Okay, sorry about that. Now, back to this one. Is this a regular integral or is this u substitution? U substitution. So do the u substitution, then plug in the 3, then plug in the 1. This is a review of 5.2. This is a review of 5.2. So again, you need to know 5.1, you need to know 5.2, in order to do 5.5. If you're like, hey, all we're doing is plugging in the upper number minus the lower number, you're right. But if you don't know how to take the integral, you can't do that. So do the u substitution first. We did like 10 of these last time. And then you can plug in the numbers, then you can check them together. Everything builds. Everything builds. So if you don't know how to do u substitution, that's going to be your problem. Oh boy. Okay, u substitution. You got 1 more minute. Let's see how we're doing. What is u going to be? X cubed minus 5. So remember our steps. It's the derivative of u with respect to x. The derivative is 3x squared. We know that it's going to always be dx equals du over 3x squared. Questions on the first step? Then we do our substitutions. This would be u to the 4, 3x squared, du over 3x squared. What ends up happening? What ends up happening? The 3x squared and the 3x squared become 1. We haven't taken the integral yet. U to the 4 du. I have not taken the integral. What's the integral? U to the 5 over 5. Don't forget your plus c. So instead of u, we're going to put in x cubed minus 5 raised to the 5 over 5 plus c. Stop there. Any questions on the u substitution? Does anybody in the class notice anything? Notice something? What do you notice? Didn't we do this last class? It's the same one as last class. So if you got it right, fantastic. You've already done it once. If you got it wrong, it's exactly what we did last time. So did you learn it last time or did you copy it and smile? Right? So if you don't know how to do it now, there's a red flag saying, oh my gosh, it's one of the ones we did last time and I still don't know how to do it. Right? So please study. Okay? Now, the new part is now we don't need the plus c because we have numbers. And again, if it bothers you, put the plus c, it's okay. But the new part is plug in the 3, plug in the 1, and subtract, and check it in the calculator. When you check it in the calculator, check it from the original. Okay? Okay, so again, what we're learning today is after you take the derivative part, plug in the top number, minus, plug in the bottom number. Now, I don't want to try to say that this is easy. I'm never saying that this is easy or hard. There's a lot of little mistakes that can happen, but this is kind of calculator stuff, right? So you need to kind of determine yourself, should you do it and type it in all at once? Should you do piece by piece? For example, you may want to do 3 raised to the 3 minus 5. That's 22 raised to the 5 over 5. You may want to do parts of it on your own. 1 minus 5 is negative 4 to the 5. You may want to do it piece by piece. You may not want to do it all together. So I'm not trying to say that this is easy by any means. But what I am saying is you can do it. Are you getting 1,030,726.4 for the first one? And then are you getting minus negative 204.8 for the second part? And then when you put those all together, plus. Is your final answer a really big number? $1,030,931.2. Is that what you're getting? And again, be careful typing it in. Not saying it's easy, just saying practice. But the good news of it all, can I check it in the calculator? Can I check it in the calculator? And the answer is yes. When I go to check it in the calculator, also be careful. The more practice, the better you'll get at it. So when I go back to the original, let's type it in. Math 9, 1 to 3, 1 to 3, in parentheses, x raised to the third, minus 5, parentheses, raised to the 4, parentheses matter immensely, parentheses 3x squared, x. The good news is you can check it all in the calculator. Are we okay? But what are we learning? We're learning that you need to know integral and use substitution. You got to know that. We're learning plug in the top number minus plug in the bottom number. That part I bet you got. That's today's lesson. But you're also learning that, if I type it in wrong, it comes out wrong. Be careful of the way we type it in. That's been the theme all semester. We okay? We did 2 of each now. We've done 2 of each. Now, we keep doing it. We keep doing it, which is good. But we also have to talk about y. Okay? So, to get the y part, we need a word problem. To get the y part, we need a word problem. Okay? So, what's the point in all this? A management service found that maintenance costs increase at a rate of m prime x 90x squared plus 5,000, where m of x is the total accumulated cost of maintenance for x years. First of all, this is cost or marginal cost? Marginal cost. It's a derivative. It's a derivative. Are we okay? I want you to write a definite integral that represents the total maintenance cost at the end of the second year to the end of the 7th year. So number 1, I gave you marginal cost, but what do I want? Cost. How do you go backwards? Integral. And I only want it for the 2nd to 7th year. So write what that would look like. Write what that would look like. I gave you marginal cost. I gave you marginal cost. I want you to go backwards to cost. And I only want the answer from 2 to 7. I only want the answer from 2 to 7. Oh, actually, it's 3 to 7. Sorry about that. It's end of the second, so let me not lie to you. End of the second means 3. So 3 to 7. Sorry about that. 3 to 7. End of the second means 3. Okay, so am I going to be taking an integral? Am I taking an integral? Why? Because I'm going backwards from marginal to cost. And what are the years? 3 to 7. Which one goes on the bottom? 3. And which one goes on the top? 7. Lower bound, upper bound. And we're taking the marginal cost, which is 90x squared plus 5,000 dx. Okay? I want you to solve the problem. Again, integral then plug in. Still struggle with the integral, I'm gonna struggle in 5 times. Okay, calculator, show me work. Watch out for the mistakes. Okay, see how we're doing. So the integral would be 90 x to the third over 3 plus 5,000 x. Normally we have a plus c, but because we have numbers, we know the c would cancel, but if you need to put the plus c there so you don't mess up the other ones, that's fine. Again, I always like to simplify first. 90 divided by 3 is 30, x to the third plus 5,000x from 3 to 7. Plug in the 7, 30, 7 cubed plus 5,000 times 7 minus 30, 3 cubed plus 5,000 times 3. Take out your calculator, type it in. Be careful typing it in. It takes practice to use your calculator. This gives you 45,290. The other side gives you 15,810. 45,290 minus 15,810 gives you 29,480. If you haven't already, check it in the calculator. Check it in the calculator by plugging in the original. When we check it, you plug in the original, make sure you type it in. It's math 9, 3 to 7, 90 x squared plus 5,000 x. There's your 29,480. Everything can be checked. Then the sentence, what does this number mean? Is that the total cost or the marginal cost? The total cost, because remember we took the integral to get total cost for which years? 3 to 7 is 29,480. So another application of integrals is to work backwards. So you can find the total cost from year 3 to 7 is 29,480. 29,400. Okay, questions on this one? Now, some of us are really good with the calculator, some of us are still learning. So let's do one just in the calculator. Let's do one just in the calculator. So in the calculator only, let's do the integral of 1.5 to 4.3 of x over ln of x dx. Let's just do it in the calculator just to practice. Just in the calculator, and let's see, we should all get the same answer. We should all get the same answer. will come with practice. If we're not that great so far. And all the keystrokes. You should get 8.02, let's say. 8.02. Sure. So calculator 1, calculator 2. So calculator 2 would be math 9. First type in the function x divided by ln of x, comma x, comma lower 1.5, comma upper, commas above the 7, 4.3. Same answer. Okay? Now, the last topic, to be honest, is not a major topic, but it's going to give us some practice. It's going to give us some practice. The last topic is finding the average value. It's not a major topic for me to figure out average value, but it should make at least sense to you. If you want to find out average, the average is find out the answer and divide by b minus a. So find your answer and divide by b minus a. So if this was 3 to 7, you divide by 4. If this was 5 to 12, you divide by 7. It's just an average, right? You divide by how many there are, right? So if there was year 1 to year 4, how many years are between 1 to 4? 3, right? You just subtract. So the only difference with average is that you divide by how many years? What's the number between? Okay? So we're going to use this as practice. So if I wanted you to find the average value for this would be the integral from -2 to 3, 6x squared minus 2x dx. Now, I'm going to add the average part later. Let's do a review problem. Just do this one, and I'll add the average part later. So just take the integral from -2 to 3 of this, check it in the calculator, and I'll add the average part at the end. But I'm using this more for practice. And just like last class, we did 10 of them. You got it, but if you haven't studied since, you don't got it. Okay, forget about the average part for now. I'll add that at the end. Let's use this as an opportunity to practice, and then I'll add the average part. So let's just use this as practice for now. Okay, let's see how we're doing. So if you take the integral, that's 6 stays in front, x3 over 3 minus 2. The integral of x to the 1 is x2 over 2. Normally you'd have a plus c, but we know since we're dealing with numbers, 6 divided by 3 is 2x to the third minus 1x squared, and we have from -2 to 3. So did we take the integral correct? Any questions on taking the integral correctly? If you got the integral wrong, it's all going to come out wrong. On purpose, I don't put the plus c because I know the plus c will cancel. So I first plug in the 3 everywhere there's an x, minus plug in the -2 everywhere there's an x. So the left side, you type that all in at once, carefully, double checking your work. You get 45 minus what do you get for the other number? -20. So that'd be 45 plus 20. What's your final answer? 65. So that's review. That's review. That's review. Let's check that in the calculator. Any questions on how I got 65? So if I checked it, math 9, -2 to 3, 6x squared minus 2x, x, so there's your 65. Okay? Now, any questions on this problem? Okay? If I was going to add that this was average value, I would take that answer divided by b minus a. I would take that answer divided by b minus a. So 65 over, what's b? 3 minus a, -2. That would be 65 over 5. And 65 divided by 5 is what? 13. Okay? So if I added average value, you would divide by 5. Understand, why am I dividing by 5? What's the distance between -2 and 3? From -2 to 3 is a distance of 5. Okay? So if it had an average value, you would divide by the 5. If it was 1 to 7, you would divide by 6 years, right? Average value. And you know what average is. Okay? Last problem. And again, let's review and I'll throw in the average part later. So this says, given the supply equation, S of x equals 10 e to the 0.05x, find the average price over the supply interval from 25 to 35. So again, let's forget about the average part just for now. Let's forget about the average part just for now so we can practice. I give you the supply as it's changing, but I want to take the integral to work backwards of 10 e to the 0.5x dx. And we're going to take it from 25 to 35. 25 to 35. Now, I do not know, unless you memorize all your special stuff, what the e to the 0.05x is. I don't know what that is. So this is going to be u substitution. This is going to be u substitution. And I'll even give you a head start. What is u going to be? 0.05x. So I'll even give you that head start. Do the u substitution, plug in the numbers, subtract 25 to 35, the integral of 25 to 35, 10 e to the 0.05x dx. It is u substitution because I don't know the e to the 0.05x, so we're going to do u substitution. And then I'll take care of the average part a little bit. Don't worry about the average part. But use this as practice for u substitution. Okay, see how we're doing. So u equals 0.05x, so du over dx is 0.05. Therefore, dx equals du over 0.05. Questions on that part? When we do the substitution, it's 10 e to the u du over 0.05. And I do want to stress, I've stressed this a lot, but I want to keep on stressing it. 10 divided by 0.05 is what? 200. But have I taken the integral? No. Make sure you keep writing that integral symbol until you actually take the integral. That's just cleaning it up. 10 divided by 0.05 is 200. The 200 stays in front. What's the integral of e to the u? E to the u, don't forget to put your plus c. But since we're dealing with numbers, we're going to put 200e. Instead of u, we're going to put 0.05x. Take it from 25 to 35. So questions up to that point? Then we're going to plug in 200e to the 0.05 times 35 minus 200e to the 0.05 times 25. Again, be very careful typing it in. We don't want to make little mistakes. The first one gives us 1150.92 minus the second one gives us 698.07. You subtracted those, you get 452.85. Questions there? Everybody get the same thing? And the good news is, can I check it? Can I check it? Yep. To check it, we go back to the original. Math 9:25 to 35, 10 e to the 0.05x dx, 452.85. Okay, so we just want to practice that. Make sure you have all your work. Practice, practice, practice. But if I did add average value, then it would be the 452.85 over 35 minus 25. And from 35 to 25, how many years has that been? 10. So you just divide it by 10, and you get 45.29, or whatever you round it. Okay? If it had the average value. Stop there.